Good morning, everyone, and thank you for, yeah, okay, thank you. Thank you for being here today, and a special thanks to the organizer for the kind invitation. I am a senior clinical researcher at IRCC at San Rafael in Rome, which is a healthcare and research institute specialized in neuroscience and neurorehabilitation. And my research activities and focus is on exploring the effects of robotic devices and innovative technologies, mainly in people with neurological diseases and conditions. Today I'm pleased to share with you some reflections, data, and clinical rationale about the robotic-assisted rehabilitation for the neurorecovery of upper limb and, of course, for the hand function, with a special focus on R-Touch technology. This is the roadmap of the next 20-25 minutes. I'll walk you through some evidence and clinical rationale, and then our latest research. Well, just a quick question, only to get a sense of where we stand today. How many of you used robotic for rehabilitation of upper limb? Wow, great. I didn't expect, actually it's a good number, but don't worry for who is not keen or has no experience to use that. I will talk about some experience of mine, and well, maybe we can change your idea after the end of this sessions. How to get back, please? It's going, okay. Yeah, let's start with some current state of the art. The motor recovery after stroke, which is a leading cause, the second leading cause of disability worldwide, is really crucial in the multifactorial process, very complex. Of course, the robotic rehabilitation is not limited to only people with stroke, but I believe that stroke is a very important condition to discuss the effect of robotic and explore its rationale. Interestingly, while the manual dexterity and hand function is one of the hardest function to recover after stroke, only small fractions of clinical trials focus on the distal neurorecovery. And yet we know all that it is very essential for a real functional independence to regain the distal and hand function. So that brings us to the brain's incredible ability to reorganize neural pathways after an injury, yeah, what we call all neuroplasticity. But in order to stimulate the neuroplastic mechanisms, we need intensive, repetitive, and goal-directed movements, what exactly robotic rehabilitation can provide. Many colleagues express still some doubts about the effective impact of robotic assisted in rehabilitation, but literature is already clear about the effect of robotic rehabilitation, since it's able to deliver, of course, more repetitions than a traditional approach, requiring active participation from the patients. So not only the patient is being rehabilitated with more repetitions, it's all he or she is also involved in a very active way during the rehabilitation process, enhancing so the cortical recruitment through multisensory stimuli and biofeedbacks such as visual, auditory, and tactile stimuli. And in the same way, at the same time, the patient during the rehabilitation has, both patient and clinicians have the possibility to receive quantitative, objective data on the performance of the patients and also about its progress, his or her progress. All of this are provided with a reduced workload on therapists, while maintaining an efficient rehabilitation process. Supporting the patient with a smaller workload on therapists. I did just a quick research on Scopus, filtering the articles for only clinical trials, so excluding engineering and systematic reviews, engineering papers and systematic reviews. And as you can see, of course, for upper limb rehabilitation, robot-assisted rehabilitation. And I found about 280 documents, which is a good number since 2002. This is a list of the top 10 countries that are most involved in the research in this field. I would like just to show that although the strict filters, many studies have also considered other related aspects, as you can see in this diagram. Hopefully, the most relevant fields are about medicine and health professions. Also a good number of papers considered during the clinical trials, also engineering aspects of the study, which is not surprising. It highlights how essential it is, the multidisciplinary collaboration between other professions and especially with engineers, with bioengineers, when we decide to integrate robotic rehabilitation and technologies into a rehabilitation process. A very recent systematic review published on neurology, which is a very prestigious journal, has confirmed, with the focus on the robotic-assisted rehabilitation for the neurorecovery of upper limb and hand function in stroke patients, has confirmed the positive effects of robotic rehabilitation. But what made me curious about this study is that the authors, out of 90 randomized controlled trials, has found only 14 studies that targeted the distal function and hand neurorecovery. So this is why a device like R-Touch gain attention in this moment of the literature and also from the clinical point of view, because this study shows that manual dexterity is crucial for upper limb function. And about 60% of upper limb recovery has been explained by the hand improvement. Well, before actually diving to the clinical trial we are currently carrying out, I would like to highlight that the interest of integrating devices such as R-Touch for the specifically designed for the hand rehabilitation is not only because of the evidence, preliminary results and evidence in literature, but is also because of the clinical and neurophysiological rationale behind it. So far, there are some preliminary and early studies that have explored the effect and the impact of R-Touch, mainly in people after stroke and also after traumatic brain injury. But the shift from the feasibility studies to the large-scale clinical trials is also because of the promising effect these studies have found, and also because of the growing demand of clinicians for having more effective tools for a more efficient neurorehabilitation. One of these studies has been included in that recent systematic review I found I earlier showed you. The authors included 30 patients with stroke in a subacute stage, studying the feasibility and efficiency of R-Touch for hand rehabilitation in this small sample. And they showed that the use of R-Touch in clinical rehabilitation is feasible, and it reduces the disability of arm and improves the hand movement and fine motor function. Of course, many studies are being conducted on stroke people, but R-Touch is not designed only for people with stroke, but also across many different neurological conditions. So also for people with traumatic brain injury, we can use that. With people with spinal cord injury, with peripheral nerve damage, also in pediatric field, because it is adaptable to any size, from small size to big size. So also children with neurological conditions can benefit this kind of rehabilitation. And with any level of disability, this is a characteristic I love about this, this device. Well, some key features that I believe are very interesting about this device, considering my experience with several robotic devices applied to my clinical researches. It's about, at the first level, as I showed you before, it's a device not only for upper limb and upper limb and arm rehabilitation, but it is also and specifically designed for the hand function rehabilitation. And it is adaptive to any level of disability. It provides a real-time feedback, also about the performance of the patients, while very interestingly, patients are able to manipulate real objects. So simulating real-life scenarios of the activities of daily living in a very gamified environment, so in a fun environment during rehabilitation. So we're talking about robotic glove for hand function, a soft robotic glove for hand function. You can see here that, as showed also Professor Molteni, in this picture, you can see many characteristics that patient can benefit from the neurophysiological point of view, because manipulating objects, simulating real-life scenarios and activities of daily living requiring active participation from the patients with biofeedback stimuli are really important features in order to induce neuroplastic mechanisms. Also, the hand mobilization. Well, we have a device that provides very near neurophysiological movement of hand. So extension, flexion, grasping, releasing, pinching, all can be provided by this device during the rehabilitation. And what is very interesting, do you know how many repetitions are needed in order for the upper limb, in order to induce the neuroplastic mechanisms? How many? 80,000. Wow, that's really too much. Literature showed that 1,000 repetitions are needed for the upper limb movement in order to achieve the first neuroplastic mechanisms in our brain. And in 30 minutes, R-Touch is able to provide 500 repetitions in a single session of 30 minutes. So if we try to prolong the session, so we can also arrive in one session, achieve the neuroplastic mechanisms that we expect. Of course, neurophysiological studies with EEG, electroencephalographic details are needed in order to confirm this, but this is what literature rationals can guide us to understand that its impact on rehabilitation. Also, the mirror therapy. I really like this characteristic of the device because there are actually small number of devices I know that has integrated mirror therapy in their program. This is a very interesting neurophysiological principle. The device recognizes the movement of the patient's healthy hand and reproduces it in the affected hand. The active assisted mobilization mode also is an approach very interesting in neurorehabilitation because the patient is assisted as needed. So the device helps patient conclude the exercise when the patient needs help. So requiring an active participation from the patients and a voluntary effort from the patients. Another mechanism of action of the art touch that I really would like to highlight is the very fun environment with which the patient interact. So the serious games integrated in the systems in the system is very interesting. So the movement and the rehabilitation exercises are goal-directed and in a virtual reality, non-immersive, of course, virtual reality environment. Also the manipulation of real objects, so stimulating activities of daily living, and also the action observation therapy are other characteristics, neurophysiological characteristics of the system. So based on these results, we launched an international multi-center randomized controlled trial. Why? Because we need a strong, reproducible, methodological model in order to give significant results and in order to go further the limits of literature that always we can see inside scientific papers that we need further research to confirm our results because of the small sample size. We need further research because of the heterogeneity of the sample. So we would like to recover this gap of the literature. And I'm so happy to show that we are already 21 centers worldwide as participating center in this clinical trial. And I'm so glad to show that even all the problematics and different procedures and ethical considerations among different countries worldwide, we hopefully received and achieved this milestone to receive the approval from Ethical Committee of Coordinating Center of the study. The study is also promoted by European Society of Physical and Rehabilitation Medicine and registered on clinicaltrials.gov as good clinical practice once and indicate. Of course, the more we are, the faster we can achieve meaningful results. The main objective of the study is to explore the efficacy of robotic rehabilitation for upper limb and hand neuromotor recovery in individuals with subacute stroke, so in a very early stage after stroke. We have also other goal for the study. One of the most important is to identify which kind of patient can benefit more and to integrate robot-assisted rehabilitation into the clinical standard process. The inclusion and exclusion criteria are strict in order to ensure the homogeneity of the sample. So we, as I told before, we include patients both with hemorrhagic and ischemic stroke under 90 days from stroke onset. The intervention includes 80 sessions over 6 weeks, 45 sessions minutes per session, of R-Touch rehabilitation, R-Touch assisted rehabilitation, plus standard rehabilitation, including physical therapy and or occupational therapy. And the conventional group, so the control group will receive the conventional rehabilitation, including physical therapy and occupational therapy with matched duration and intensity. The assessments are to be considered at baseline, post-treatment, and at 3 months follow-up. All selected based on ICF principles in order to recover the 3 main domains of international classification of functioning, so body function, activity, and participation, with a Fugl-Meyer assessment, motor part, as the primary outcome of the study, to measure the improvement in upper limb and specifically for hand neuromotor function. Our very first experience are really positive and encouraging. The R-Touch is being showed to be well tolerated, both from patients and also from physical therapists, which is not, which is appreciable, because not all physical therapists are so keen to use robotic devices in the clinical routine. But in this case, we are receiving very positive feedback. It is a program highly personalizable and adaptable to any level of assistance, incorporating different movements within ecological scenarios to enhance motor adaptability, so patients feel, in a way, in a real-life context. And we never found adverse event so far during our study. What we expect is to achieve greater neuromotor improvement of the upper limb and manual dexterity in the experimental group. And also, another key goal of our study is to achieve at least a minimally clinically important difference for Fugl-Meyer assessment motor part, which is about 10 points. And we hope to integrate the robotics into standard rehabilitation in order to move forward a personalized rehabilitation. If our results will be achieved, we believe to be a voice, important voice for the future of rehabilitation guidelines, because we expect to achieve a very high number of patients, around 150 patients, and the more we are, the faster we can achieve these results, and the faster we can give rehabilitation a robust and a strong message. One voice, one message. So this is why we are working hard in order to make a global trial worldwide. And we would like also to be a step forward in the integration of technology in rehabilitation, as I repeat many times. So to conclude, the precision healing for revolutioning the rehabilitation, putting the patient at the center of rehabilitation, and taking into account the real needs and expectations of each individual during their rehabilitation is what the future rehabilitation should pay attention to. So I finish with a message that reflects the spirit of my mission and vision, is translating insight from global collaborations into clinical practice. Thank you very much for your attention, and I'll be happy to discuss with you about your experience.